Okay, pre-calc people. I'm going to go over some of the basics of chapter 1. I'm not going to go over the problems in specific right now. We can do that in other videos. Just want to go over the general ideas, and hopefully you can take those and do the problems on your own. The idea, some of them are really hard, and you'll probably need help, or a lot of people will need help on some of them. But I want to give you at least a chance to try them on your own first, and then if you struggle and can't get them, then I can help you out more in the particulars. But overall, chapter 1 is on units. It's extremely useful for all of math and especially science, and you got to be able to deal with units. And in real life, these are skills that you should have. You probably know how to do this already, but maybe you haven't done it in much detail and haven't done it in a while. So, okay, here's how you go. And this is my first video that I'm doing here using a whiteboard and everything. So hopefully this works. I'm going to practice standing out of the way and trying to write big enough. Hopefully you can read all these things. This will be a work in progress. But all right, so units. So first off, well, I'll just do some examples. So let's say that you want to change, you want to know if you are going 1 inch per second, and I'll always write seconds with an S. And instead of writing SEC because it's easier, an inch, you probably could do IN, whatever. 1 inch per second. So how many, let's say, kilometers per hour is that? Make it interesting. How many kilometers per hour is 1 inch per second? Now, an inch a second is pretty slow, and kilometers per hour is like what they measure speed in cars in Canada and the rest of the world. So probably not very many, right? So we can guess it's going to be a small number, but let's go over how to do this nice and systematically so you can't make a mistake. So the way you do it then is you write down like I did inches per second as a fraction. It's much better as a fraction than as a slash because it's easier to cancel as a fraction. And then you start writing down things that are equal to each other. Okay, so let's say inches. We want to get to kilometers, which is metric. So maybe, I don't know how many kilometers in an inch, but I know that an inch is 2.54 centimeters, and you probably know that number too. So let's use that. So we multiply by, let's see, 2.54 centimeters is 1 inch. And notice that I made that C really big for some reason, but well. Okay. Now, I knew to put the centimeters in the top and the inch in the bottom because I'm going to want the inches to cancel. Okay, so I want to have the inch on top and an inch in the bottom. And this is like multiplying by 1. If you multiply by 1, you don't change anything. So since 2.54 centimeters is the same thing as an inch, I'm multiplying by 1, not changing anything. And again, the way I knew to put the inch in the bottom and the centimeters in the top was so the inches cancel. So now I have centimeters per second. If I stopped right now, I'd have centimeters per second. But we want kilometers per hour. So let's change centimeters to meters because I can do that pretty easily. Let's see, I know from a meter stick there's 100 centimeters in a meter. So I'm going to put 100 centimeters in the bottom so it cancels. That's 1 meter. Centimeters cancel. So I know I did that right. Now we have meters per second, but I want kilometers, and kilo means 1,000. So I know that now I can multiply by 1 kilometer, or kilometer is the same as 1,000 meters. And I'm pretty sure I did that right because the meters cancel, and a kilometer is the same as 1,000 meters. Now we have kilometers and seconds. So, but we want kilometers per hour. Okay, so now we got to change the time. We have seconds on the bottom. So let's see, I know that there are 60 seconds in 1 minute. And I know that there are 60 minutes in 1 hour. I'll write out hour. And now I checked that I did that right. So the minutes cancel, seconds on the top, seconds on the bottom, way over here. And I'm left with kilometers in the top and hours in the bottom. So I know I did it right. So 1 inch per second is this many kilometers per hour. So now you get out a calculator and you multiply all those numbers. So let me do that here. And you can check and make sure I'm doing this right. So let's see. I have a 1, and I don't really need to put that in. So 2.54 first. So 2.54 times 1, which I don't need to do, but I can go divided by 100. So divided by 100. So 2.54 divided by 100. Let's see, here we divide again by 1,000. So divided by 1,000. Multiply by 60 and then multiply by 60 again. So times 60 times 60. And I get 0.09144. So finally, 1 inch per second is equal to 0.09144. 0.09144 kilometers per hour. Okay, so that's how you change units. You multiply by fractions. Every fraction is equal to 1, and you make sure that you put the things in the top and the bottom and everything so that things cancel out. And then you cancel them all out and make sure you're left with what you want. The only ones not canceled are what you want. If you're really neat and orderly like this, it makes it a lot easier. Takes like 10 seconds longer to write all the stuff out, but it saves you all kinds of time and not getting it wrong as often, or hopefully getting it wrong at all. Okay, let's do another example, and hopefully you can all read this. I think this will work out pretty good. Erase this one. And let's say you want to change minutes per mile to miles per hour. So let's say you go out and you run a mile, and it takes you 5 minutes to run 1 mile. So you're running 5-minute miles, which is pretty good. I can't do that. I think I can run a 6-minute mile. That's about the limit for me. But let's say you ran a mile in 5 minutes, a 5-minute mile. How fast are you going? Like if you're in your car, are you going 6 miles an hour, 5 miles an hour, 15 miles an hour? How do you change that? This is what's called your pace. They call this your pace. You're running 5-minute miles. That's your pace. While your speed is miles per hour, right? So first, the problem here is we have miles per minute, not minutes per mile. So we have to flip it upside down to get miles per minute. But let's change this to what we want, which is miles per hour, or hours per mile, and then we'll flip it upside down, if that makes sense. Hopefully that makes sense. So let's change this. We want, I'll say that we want miles per hour, because that's how most of us think about speed, because we're used to driving in cars and we know something about miles per hour. So the miles is just fine, but we got to get rid of the minutes. Well, that's pretty easy. So we multiply this by, let's see, 60 minutes. We know we put it on the bottom is 1 hour. Again, we put it in the bottom, so we know the minutes cancel. We have hours per mile. So that's 5 divided by 60 hours per mile. So 5 divided by 60, which is 0.08333 forever. So 0.083 repeating forever. Hours per mile. That's how many hours it takes to run 1 mile. But we want miles per hour. So all we do is flip this upside down. So we go 1 divided by 0.083 repeating. And then this gets flipped upside down too. So that would be miles per hour. So we just go 1 over 0.083333. So I'll do that. I'll go 1 divided by 0.08 and put in lots and lots of 3's. And I get, probably exactly 12, which it is exactly 12. So this is 12 miles per hour. So if you're running 5-minute miles, you're running 12 miles per hour. Now we could have guessed that, right? If you're running 5-minute miles in an hour, how many 5s fit in an hour? That's 12 5s fit in an hour, right? So 1 mile takes 5 minutes, 2 miles takes 10 minutes, 3 miles takes 15 minutes, and you get up to 12 miles. So we could have guessed that because 5 is pretty easy. But if I'd said 5-minute, 10-second miles, that's not so easy. And by the way, it gets tricky if there's seconds, right? So if we had said 5-minute, 10 seconds, so 5:10 minutes per mile, we have to change that to a decimal first. We got to change the 5:10 to a decimal. So 5:10 is 10/60ths of a minute. So really we'd have to change that to what's 10 divided by 60, 0.16666 forever. So that'd be 5.16 repeating minutes per mile. And that's what we have to use since, seconds and minutes are out of 60 and we want to make a decimal out of it. So it always gets trickier than it should. So, okay, that's how you do that one. Hopefully that makes sense. Let's do one more example to help you on your way through the chapter 1 problems. Chapter 1.2, problem 1.2 is pretty tricky. I'll let you wrestle with that one, then we can probably do that one. I'll make a video on that one. But first I want to give you a chance for that, see if you can get it right. It's more than just simple conversions. So a lot of these are simple conversions, and a lot of them are pretty tricky, and you got to really think to do these problems. Okay, one more example. Get the idea of this. Let's say you go to Canada, which you're not allowed to do right now, but let's say you were there last summer and you saw that you went to go buy a car and they said that your car got 17 kilometers per liter of gasoline. Okay, 17 kilometers per liter. And you're wondering if that's good gas mileage or not. Is that a good car? Is that a gas guzzling car? Is that you're going to waste all your money on gas? Or is that a pretty good deal? Kilometers per liter, right? We're used to miles per gallon. So we want to change that to miles per gallon. Okay, now you're always welcome to use Google to search for conversion factors because we got to know something about gallons and liters. Those things are not obvious to come by. How many liters are there in a gallon exactly? Yikes, I'm not even sure I know that. I have to go look that up. Kilometers and miles I do know, or at least to a reasonable amount. But liters to gallons. A liter is about a quart. There's about 4 quarts in a gallon. The liters are a little bit bigger than quarts, so my guess is it's like 3.8 or something. But we'll look that one up. Okay, but first, we got to multiply by something that's the same. We want to change kilometers per mile. And I know from running races that 10 kilometers, if you run a 10K, it's about 6.2 miles. A 5K, a typical race you're doing cross country, is a 3.1 miles. So 10K is 6.2 miles. So I can multiply, let's see, kilometers in the top. So I put 6.2 miles in the top is the same as 10 kilometers. Okay, that's multiplying by 1. They're the same thing. Kilometers are going to cancel enough with miles, and now we got to cancel out liters. So we could say 1 liter is so many gallons, or a gallon is so many liters. So let me go Google that really quickly. Okay, so it says that 1 gallon is 3.7854 liters, which makes sense. A liter is a little bit bigger than a quart. Gallons, 4 quarts, so a little bit less than that liter. So, okay. Let's see, liters in the bottom, so we want to put liters in the top. So 3.7854 liters divided by 1 gallon. Now let's cancel. I'm going to do that with blue marker so you can see it. Let's see, liters cancel. We have kilometers canceling. We're left with miles per gallon. Okay, cool. So now we just multiply. So we take 17 times 6.2 divided by 10 times 3.784. We don't need to divide by 1. So times 3.7854. and I get 39.89, let's say 39.9. So about 39.9 miles to the gallon. So that's about, oops, I need to use my block. What did I say? 39.89, or 39.9, about 39.9 miles to the gallon, which is pretty good. Right? That's pretty good. There's cars that get better, but that's certainly better than most cars. So if you go to Canada and they say the car gets 17 kilometers per liter, you can say, oh, about 40 miles a gallon. That's decent. Okay, that's kind of the idea for converting units. We're gonna do that pretty much the entire year. You'll do this in science classes. Really good skill to have. A lot of the chapter 1 problems, again, are not just doing lots of examples of this. They're using this to do lots of other types of things. So again, just be aware of that. We'll do more of the examples in chapter 1 and later video and stuff to help you out, because some of these problems are pretty tricky. But this is the overall idea. Write everything as a fraction, multiplying by 1. Make sure you have the things on top and the bottom to cancel. And then when you cancel them, the ones that are left are what you have. You make sure that's right, and it's really hard to make a mistake. Okay, hope that helps. We'll see you in another video.